So for number 2, this is a quadratic because it is to the second power, right? But it's in standard form. And so if I want to know the axis of symmetry, I'm going to use this equation, x equals the opposite of b over 2a. All right, so in this equation here, I've got that a is 1, right? B is 4, and C is -5. And so the axis of symmetry, if I do the opposite of B, that would be -4. And then 2 times 1 is 2. So that would be -2 for the axis of symmetry. X equals -2. And so that's also the x-coordinate of the vertex. All right? So now if I want to know what the y value is, I would put that -2 into my equation. So I could do, go to my calculator, and I'll go y equals, and I'll put in this equation, x squared plus 4x. So x squared plus 4x minus 5. All right, and then I can go look at the table, and I've got when x is -2, right? When x is -2, y is -9, right? And so that will be my vertex. -2, -9. And since A is positive, I know it goes up, right? It's opening up. And so my end behavior is going to be positive infinity on both sides, right? And the domain, since it goes forever, the x values left and right go forever. That would be -infinity to positive infinity. Okay. And then set notation, that would be x is an element of all real numbers. Okay, that's the domain. And then my range, right, my y values, range is looking at up and down. So I know that if it's opening up, I know my vertex is a minimum, right? So the graph opens up, so my vertex is a minimum. So range-wise, this -9, right? The vertex is a minimum, so it goes from -9 to positive infinity because it goes to infinity. It actually includes -9, so I'm going to change that to a square bracket because it includes -9. And so that would be with set notation, that's all the y's that are greater than or equal to -9. All right, and so now if I want to look at that, I will just put it in my, I have it in my calculator, I'll just look at it and graph the points that I see here. So my vertex is at, it's this point here in the middle, and then you can see how it's symmetrical because you got the 8s, right? The -8s, the -5s, and the 0s. Okay, that's why it is symmetrical, just like with absolute value. So I'm just going to graph those points. I forgot, I wanted to show you how you could do this. If it's a nice slope of 1, you can go to your vertex, and so we've got -2, -9, right? And if it's a vertex, if it's a slope, if A is 1, you're going to go up 1, or over 1, up 1, and then over 1, up 3, 1, 2, 1, 2, 3, and then over 1, up 5, 1, 2, 3, 4, 5. And then over 1, and then up 7. 1, 2, 3, 4, 5, 6, 7. All right, and so then I could go over here on the left, over 1, up 1, and then over 1, up 3, and then over 1 and up 5. 1, 2, 3, 4, 5. Oops, there it should be right here. Right, because it's symmetrical, so they're going to be, discounted that. right? And then I'm going to go over 1 and up 7. 1, 2, 3, 4, 5, 6, 7. All right, so you go up 1, up 3, up 5, up 7. Okay, 1, 3, 5, 7. And that's, and then you connect the dots here. All right, and notice it's going to positive infinity for my end behavior. And now I'm looking for my, oh, and here's my axis of symmetry. Right, the axis of symmetry is your vertical line going through the vertex, which is a minimum. Okay, so now the points we're interested in are these, the y-intercept, right, which is where x is 0, right? X equals 0. And so when x is 0, what is y? Well, it's nice to see here, if x is 0, that's 0, that's 0, so y is negative 5. And then you can see here, 1, 2, 3, 4, 5. Y is negative 5. And then for my x-intercepts, that is where y is equal to 0. All right, and so when y is equal to 0, these are the x-intercepts. All right, so y, when the x values would be 1, 2, 3, 4, 5. So x is negative 5, and y is 0, and then x is positive 1, and y is 0. And you can see that also on your table. Right, well, here's where y is 0. So these are my x-intercepts, right? X-intercepts. And then my y-intercept is right here where x is 0. All right. Very good. Let's try some regressions.